The 1970s were when a lot of the modern US way of war was born. Precision strike, space support, integrated air defense, and global command and control all took recognizable shape in that decade. The United States military would develop and employ high-tech lethality on a level never before seen. They would establish a strategic, operational and tactical superiority that no rival nation or enemy combatant would dare to engage. Let's get into it. Space and satellite technology. Early missile warning IR satellites. The DSP, or Defense Support Programme's first satellite, launched in 1970, giving continuous infrared warning of Soviet and Chinese ICBM launches and later even tactical missiles and other slow walker IR targets. Navigation, pre-GPS to GPS. The Air Force began developing the Navigation Satellite Timing and Ranging, or NavStar, and the Global Positioning System, or GPS concept, in 1974. The first experimental Block 1 GPS satellite went up in 1978, with extensive tests through 1979 to prove the space, control and user segments. GPS military focus. The system was conceived as a global, all-weather navigation and timing spine for military forces, air, sea, land, years before serious civilian use, enabling future precision weapons, synchronized operations, and timing-dependent systems. Reconnaissance and comms, KH-series imaging satellites and increasingly capable military comsats were providing near real-time strategic imagery and secure long-haul links, even if bandwidth and revisit rates were primitive by today's standards. Missiles and air defense improved. Hawk. The US Army finished converting its European and Korean units to the improved Hawk system by the late 1970s, adding better radars, electronic countermeasures or ECCM, and engagement capabilities against low-altitude threats. In day-to-day terms, a 1970s I-Hawk battery was a semi-mobile, radar-intensive, medium-range SAM unit. Trailers, launchers and radars dug in or semi-hardened, tied into the higher-level air picture and identification systems, ready to engage Warsaw-Pact bombers, strike aircraft, or infiltrating jets at medium altitude. Its improved ECCM, radar suite and fire control logic are why it remained relevant into the 1980s, even as Patriot came online. A typical 1970s I-Hawk battery had MIM-23 missiles, which were semi-active radar homing, command-guided in mid-course, optimized for medium altitude, and ideal for medium-range targets. The max engagement range was approximately 20 miles, and the minimum engagement was approximately 1 mile. The missile could reach an altitude near 60,000 feet at a top speed of 2.5 to 2.7 Mach. It was also equipped with acquisition and tracking radars to include the following: Pulse, acquisition radar for long-range search; CWR, or continuous wave acquisition radar for detecting fast, low-flying aircraft; HPI, or high-power illuminator radar to provide the CW illumination needed for terminal homing; fire distribution and engagement control centers, which consisted of consoles with circular plan position indicator or PPI scopes and tactical displays, where operators conducted surveillance, identification and engagement decisions; launchers, which were trailer or towed launchers with 3 Hawk missiles raised to firing angle, tied to generators and communications vans. All the while, the Patriot was in development. The SAM-D program, which became Patriot, entered engineering development in 1973. By 1977, combined tests showed Patriot acquiring high-altitude targets and cueing which improved Hawk against low-altitude ones, further sketching the modern layered high-to-medium air defense, or HIMAD concept. improved Hawk and the emerging Patriot system were being designed to work together, one engaging high-altitude targets and providing cueing information, the other handling lower-altitude threats, reflecting an early integrated air defense philosophy. Strategic missiles, Minuteman III and Poseidon. Strategic Launched Ballistic Missiles, or SLBMs, formed the backbone of nuclear deterrence, while multiple independently targeted re-entry vehicle technology and improved guidance pushed accuracy and penetration capability to new levels. NORAD and North American Continental Defense, large fixed early warning radars, semi-automatic ground environment or SAGE-type networks, and interceptor forces were being rationalized under evolving doctrinal and technological regimes, even as emphasis shifted more toward overseas theater air defense. Command, control, and computing. WMCCS, or the Worldwide Military Command and Control System, conceived after the Cuban Missile Crisis, matured through the 1970s into a sprawling network of mainframes, communications links, and operations centers providing warning, data processing, and mission assignment tools to national and theater commanders. It linked sensors, communications, and decision-makers, giving the President and the Secretary of Defense a way to receive warning, direct unified commands, and manage global forces. An early mainframe-era ancestor of today's GCCS and network-centric C2. Aircraft and airborne systems, fourth-generation fighters, the F-14 Tomcat, the F-15 Strike Eagle, and the late 1970s F-16 Fighting Falcon or Viper, and the F-18 Hornet entrants brought high thrust-to-weight, look-down, shoot-down radar, and advanced missiles like the AIM-7F and AIM-54 Phoenix that moved air combat decisively into the Beyond Visual Range, or BVR radar missile era. The American fighter jet was like no other. Precise, sleek, highly maneuverable, and all piloted by the best pilots in the world. AWACS, an airborne C2. The E-3 Airborne Early Warning and Control System, or AWACS, entered service in the late 1970s with a powerful S-band radar and battle management suite, enabling wide-area air picture and controlled intercepts over Europe and elsewhere. Stealth beginnings. The Have Blue demonstrator flew at the end of the decade, proving faceted low observable design and directly leading to the F-117, even though operational stealth wouldn't be fielded until the 1980s. The submarine force. In the 1970s, the US submarine force quietly leapt ahead in three linked areas: heavyweight torpedoes, the Mk-48, quieting and stealth, and long-range missile strike from SSBNs and SSNs. The Los Angeles-class SSN design was finalized in the early 1970s and commissioned mid-decade. It was about 50% larger than the Sturgeon class and optimized for higher speed, deeper diving, and notably lower acoustic signature. Major features included refined teardrop hull shaping, a large, slow-turning skewed propeller, machinery isolation mounts, and improved sound-absorbing materials that reduced machinery noise getting into the hull and water. Torpedo technology advancements. The Mk-48 Mod 1 entered fleet service in 1972 after successful warshot tests from the USS Trigger. By 1977, the Mod 3 added two-way wire guidance telemetry, allowing the sub to see the torpedo's sonar picture, improving mid-course control and discrimination. Submarine launched missiles. Poseidon C-3, the Polaris successor, achieved operational service in 1971 after the first submerged launch from James Madison in 1970. It carried a MIRVed RV bus, up to 10 to 14 smaller warheads, dramatically increasing warhead count per boat and allowing more flexible targeting of Soviet strategic assets. During the 1970s, nearly all Polaris boats were converted to Poseidon. By the early 1980s, it had fully replaced Polaris in the fleet. Trident C-4 development ran through the late 1970s, with initial deployment at the end of the decade, beginning the move to longer range, more accurate SLBMs that would further exploit the ocean's cover. Harpoon itself was a 1970s anti-ship missile. The dedicated submarine launched UGM-84 sub-Harpoon variant that gave subs an over-the-horizon anti-surface punch beyond torpedo range, entering service around the turn of the 1980s but rooted in 1970s development. Laser-guided and precision weapons pave way 1 and 2. Laser-guided bombs that started as a mid-1960s shoestring project matured through the 1970s into the Paveway family. Essentially, they were bolt-on, semi-active laser guidance kits for standard iron bombs, dramatically increasing accuracy when a target was illuminated by ground or airborne designators. These kits turned dumb bombs into precision weapons without needing new aircraft. Any platform that could carry the bomb and work with a designator could deliver precision strikes, laying the doctrinal groundwork for later Desert Storm-style warfare. The broader pattern. Across these domains, the 1970s United States military was knitting together space-based warning, navigation, and, to some extent, surveillance. Precision strike at the tactical level via laser guidance, layered ground and airborne air defense, and early warning. Undersea stealth, precision, and dominance. Global command and control built on mainframes and dedicated comms networks. By the end of the decade, the core technology stack for how the US fights today. Space support, precision weapons, advanced fighters, and integrated C2 was in place, even if the full capabilities wouldn't be realized until the 1980s and 1990s.